So today we're working on work, energy, and power, right? So before we do that, there's just a couple of things we need to go to. Just a bit of revision in terms of the different types of energies that you guys have learned about. So the first type of energy is kinetic energy, which is just basically the energy of an object due to its motion. If something is in motion, it has to be moving, right? If it's moving, it means that it has a certain velocity or even speed. So whenever we talk about something that has kinetic energy, it means that that thing has to be in motion, meaning it has to have a velocity. So for example, here I've drawn a picture with a 5 kilogram object that has a velocity of 0. I'm pretty sure you guys can already think, if I were to ask you, does this object have kinetic energy at point A with a velocity of 0? Because we said kinetic energy is the energy of an object due to its motion, meaning it's the energy when it has velocity, here the kinetic energy would actually pretty much be 0. But let's prove it, right? This is the formula for kinetic energy. That stands for the kinetic energy. That's just a half. This is the mass of the object, and this is the velocity. So if we had to calculate the kinetic energy of this object at point A, we'd say a half times mass times velocity squared, which is a half times the mass, which is 5, times velocity squared, 0. Then you see that the kinetic energy is basically 0 joules. But now let's go to point B, right? And that kind of proves our point. Object is not moving, there's no velocity, therefore there is no kinetic energy. Then we go to the object when it's at point B. If you had to calculate the kinetic energy here, I'm pretty sure you guys can already see that this object will have a kinetic energy because it is moving. It has a velocity of 5. So it would be a half times 5 times 5 squared, right? And from that, you'd be able to get the kinetic energy of the object. So most times when an object is moving, not most times, all times when an object is moving, it has kinetic energy. When it's not, it doesn't. So the kinetic energy here would be 62.5 joules, right? It's energy, guys. So remember, the SI unit would be in joules. Now, next part is the potential energy. Potential energy is the energy of an object due to its position. And I added in brackets relative to the ground, right? So sometimes you can look at the position of an object relative to the ground or relative to another position. But right now, I want us to look at an object's position relative to the ground. So we've got point A, where we can calculate the potential energy, and we've got point B, where we can calculate the potential energy. The formula for potential energy is mass times gravitational acceleration multiplied by the height. Height being the height of the object relative to a specific point. Right now, I want us to look at the height of the object relative to the ground. So, if we had to calculate the potential energy of the object at A, we'd say mass times gravity times height, which is 5 times 9.8, because remember, this is for gravitational acceleration. And we know that gravitational acceleration is always going to be a constant number. It's 9.8 meters per second, right? Multiplied by the height of the object relative to the ground. The height of the object relative to the ground here is 5 meters. So if you now had to calculate the potential energy of the object, it's 5 times 9.8 times 5, and you get 245 joules. Emphasis again on joules because it's energy. Then for potential energy, at B, so at this point, we'd still again say mass times gravity times height. The mass is obviously still 5. Gravitational acceleration, it's always 9.8. Multiplied by its height relative to the ground. If you look at the height of the object relative to the ground, over here, it was 5 meters above the ground. Then your object slid down and now it's literally on the ground itself. So the height of the object relative to the ground is 0. And that's why the potential energy here would be 0 joules. Okay, so that's what we see. Kinetic energy versus potential energy.